Markov chains actually. Okay. Especially the application is going to be able to Google PageRank, so we'll try to make sense of that algorithm, why that algorithm works, and what are the dynamics of it. So what we discussed last time, if you recall, what we started that if you have a Markov chain and a transition matrix, then we know that it satisfies the so-called Chapman-Kolmogorov equation. Okay. And then we headed towards classifying, the states in a given Markov chain. We first talked about kind of a classification of the Markov chain where you don't need probabilities actually. Okay, so we, for example, in order to define or to classify a state space, okay, of a Markov chain into, say, essential or inessential, essential, essential, inessential, roles that would make that when you see that it's irreducible what, okay, you can classify the states or even entire Markov chain to become irreducible actually. Or within a Markov chain you can have irreducible classes actually. Okay. So that's in order to classify the states into essential states or to inessential states or into the irreducible classes, you don't need probability. You can just look at the states and you can know that which of these are essential, inessential, and irreducible classes. Then, if we add, if you want to further classify, you want to take your classification to a new level, then the transition matrix plays a very interesting role. In other words, using transition matrix probability, you can gain another level of classification of the states. Okay. And we will see that all this classification is going to eventually give a bigger payoff, and that payoff is going to be that you can talk about the long-term behavior of a Markov chain, that how this chain is going to behave in the long run. Okay, so that's what is our key objective. Okay, and obviously, you can study the long-term behavior probabilities. We know that we can compute easily. If you know the transition matrix, you can compute the nth step transition matrix as well actually. Okay, but if you want to take limit, that n goes to infinity, that n goes to infinity, then as number of steps goes to infinity, then you have no idea that this n step transition matrix is going to go where actually. Okay. So in order to see that where the higher powers are in long run, the transition matrix would go, you have to see that what kind of states you have within that chain actually. So therefore we started doing the classification actually. So let me quickly recall, not talk about these things. Irreducible essential state, we know it's a state actually that if it refers to someone or it communicates with someone, the state communicates, that state communicates back actually as well. And irreducible means that you have a single intercommunicating class actually, okay, in which the states, all the states are intercommunicating with each other actually. Okay, so that was one thing. Then we started doing the classification of the states based on the probabilities. Then we talked about the period of a given state actually, not repeating it. Okay, so we defined also the period of a state that so it's a GCD of the all number of times in which the states return to itself actually. And a state would be aperiodic. Okay, it has a period 1 actually. has that period. But in other words, the number of steps in which a state returns to itself has a GCD1. Okay, and then we can see that periodicity, being essentialness, all these are class properties. So all these are class properties. In other words, if you have a class in which every state is intercommunicating with each other, and if one of the state in that class has, say, a particular period, it's essential or essential, the all states in that class are going to have the same properties. Okay, so that was a quick review. Then we went on to discuss and talk about classify the states into the recurrent and transient states. And for doing it, we defined this symbol that by f and ij, I mean the probability that xn will visit the state j for the first time, starting from the state a in the I in the n step set. Okay. So that's xn is j and x naught is I, and in all of the intermediate phases, it's not visiting j this way. That's a probability. Okay.
So this picture period.
The picture of it is that you have a state, okay, and you have another state actually, okay, and you are roaming around, okay, within different states, okay, and what is the probability that you're going to reach from state 1 to state 2 in, for example, 4 steps, okay, but 4 steps in such a way that that the fourth is the first time that you are visiting the state, not before. Okay, and then we also define. Okay, so we can also say that this probability is basically the distribution, okay, of a first passage time, a distribution of a random quantity Tij. Okay, so it's a first passage time. So if Tij is the first passage time, of reaching to the state j from the state I, okay, and what is the probability that you will reach the first time that you will reach from the state j to the state I in n steps, given that you are at I, okay, is basically this fi and j. Okay. So Tij is representing the time, the first passage time, or the first time that you start from the state I and you reach to the state j actually. And what is the probability that this time is n? Given that you started from I, so you denote that by a symbol f and ij, and which explicitly means this actually. Okay. So you can have it. The first time would be obviously 1, okay, but it is possible that you have this, for example, this weather chain actually. Yeah, so I can reach to the step 1 in 1 step, but I can also reach to it in, for example, 2 steps, and I can also reach in the 3 steps that go this way and then go back actually. And you have multiple numbers. Okay. multiple numbers. But like these probabilities are representing the time that you start from the state A, I and state J, but you reach to the J from the first time, and what is the probability that that number is going to be n at J. Alright? And what would be the meaning of F star ij? What should be the meaning of 1 minus F star ij? Okay, no. I must define F star. I must define F star ij. So F star ij is the probability that you will eventually reach, okay, from I to J, okay, for the first time. You will eventually reach. So what would be this expression? So imagine you can reach from the state I to J, but in 1 steps. Okay? But you can also reach from state I to J in 2 steps, and so on and so forth. So you have this series at J. This series has been given this name. Okay. So thus I'm going to reach from the state I to J. Okay. Eventually I'm going to reach from the state I to J from the first time. Okay. So I can reach in first step, or I can reach in 2 steps, and so on and so forth. Okay. So this series has been given a name actually. Okay. Obviously this would make sense when this series converges. Otherwise not that would be the problem. So what would be the meaning of 1 minus Fij star?
Never goes to
Never
zero.
reach.
Never reaches.
Never. So it's a probability that the time you will reach from I to J, given that you are at, I, is the day of judgment actually. Okay. Not even that. Okay. So that's what this is. And then for this, the question is how to compute such probabilities. So these seems very interesting probabilities that tells you that yes, you can reach infinite number of steps from a state I to state J. So the question is, if you have been given a Markov chain, how to compute such probabilities. I'm not repeating all the steps, but I'm just writing that first step decomposition. Okay. Formula. So we drive the formula. What you call the first step decomposition. Okay. First step decomposition, and that formula says that if you want to compute these Fij star, these Fij star satisfy, an equation, and that I've asked that what is the nature of this equation actually, and how you can compute it. So Pij, okay, plus, take the sum over, all those states which are different from J, but they lead to J. Okay? And you're reaching from I to K and F star I J. Okay? And there is probability that you're going to reach from I to K, and from there you can reach to the J eventually in some number of steps. Okay. So what is the crucial difference between Fn Ij and F star Ij? So Fn Ij is the probability you're going to reach in n step, and F star Ij you're going to eventually reach out. So I'm not interested in number, just so that is the problem. Now what is the nature of this? So if you have been given a Markov chain, you know that you have a transition matrix associated with it. Okay. Now, if you substitute, for example, like these quantities here, and if you keep these things as unknown, then for each I and j, okay, you're going to have a system of equation. You're going to have an equation. Okay, and hence, basically, when you're going to substitute the values, okay, of I and j, and get a system, just solve that system of linear equations, and you're going to get the these f star ij as probabilities.
Sir, K leads to J. What does that mean here?
K leads to j, that so it's a probability Bij plus k is a state different from j, and k leads to j. K leads to j means that
All those states that lead to
states
J.
that leads to j actually. Okay.
That means we are going from I to K, and K must leads to J.
J actually, yes. So you're not stuck in a kind of a state which is not going to the j actually. So make sure that you're taking the sum over all those states and leading to the j actually. Okay. And then we also defined finally that imagine you compute, for example, these probabilities. I'm going to do one example over it. I'll run through one example. Is that imagine you have this actually. So that these probabilities, first step probabilities, for the state I is 1. Okay. Then what does this mean? This means that you started from the state I, and you are going to return to the state j, or the same state, almost surely. So you're gonna return almost surely. So this means, and we gave this state, such a state, a name. So if this is that I is a recurrent state. Okay. And this f star I, if this guy is less than 1, okay, then you call I is transient state section. Okay? Transient states. Now these are the states in which the chain is not going to stay actually. It has to leave it. Okay. Now what would be the good thing about recurrent and transient states? So imagine you have a Markov chain. Okay, and in that Markov chain you computed these probabilities, and you quickly come to know that which states are transient and which states are recurrent actually. Okay? Then you will be, and you want to study the long-term behavior of such a chain actually. Then you will be only interested in what? Which states? The recurrent states are the transient states. So transient states are, that transient states are those states where, you may return or not actually. Okay? But the recurrent, states are going to play a very interesting kind of a role when you want to study the long-term behavior actually. Okay? So let's do one example and try to compute these probabilities for first start. I'll just give you an overview. You can compute for yourself for the rest. Okay, so here's an example. So consider a situation: two people are playing a game. Okay, and the game is a coin tossing game, but they are playing the game in this manner. So what they have done, they have fixed a pattern actually. Okay, they'll keep on playing the game. Okay, unless a fixed pattern that I am interested in emerges actually. Okay, so imagine I fix that A would win if this pattern emerges, head, tail, for example, and B is another player. Okay, this is head, tail. So they'll keep on playing the game. Okay, unless this pattern emerges actually. Okay, this pattern emerges, and it is not necessary that it should emerge consecutively. Okay, consecutively. So imagine that I'm tossing the coin. I got, for example, head on the first time. Actually, I'm on the player A. Okay, on the player A. Fine. In the next game, what can appear? So a tail can appear, or a head can appear actually. Okay. So if tail appeared, it's not neither of my use narrative of the player B user, because think about it, he's not interested in the tell. He want to start from
Sir, पर पहले में तो H आ गया था ना मेरे को.
किसके पास?
The first one you did, you got head,
Head.
and then second if you get tail, so B is happy, sir. If you on the second tossing, if you get tail,
he would be happy, but would that thing be beneficial for him?
If again we
No, sir.
take
Doesn't
the
he have
both
to
similar.
try?
He want heads as well actually. Okay. So it's like they have their own points actually.
Okay.
So one is tossing his coin, and then on the turn he is tossing his coin, and then he is tossing the coin. Both have their points and they are doing it actually. Okay. The question is, this is going to generate, an interesting pattern actually. Okay. So what would be the first possibility? Okay. The first possibility would be the start of the game. So you're going to start eventually from somewhere. So let's give that, state a name. One. So the start of game, I'm giving it a state 1. Okay? So in other words, you played, I played, A played, B played. Got the game. So what would be the second state? So you have to think from the perspective of the both players. Okay? So both of them can be in one state. So both of them can start. And the second state could be, for example, head. Okay?
Sir, necessary.
Necessary what?
Head
Saying is already. Probability.
probability.
That's what I'm saying. So in other words, I want to identify what are the states in this experiment, okay, in which the both of the player can be. Okay? Both of the player, both can be in the head actually. So both got the head. Okay? And what could be the third state actually?
For A, it is head, and then for B, it is tail.
So here's the thing. We started the game, player A got the head, okay. And then there is a turn of the player 2. He got what you call, say tell actually, okay. And then the tell is of no use of him actually, okay. So I'm gonna the player A is going to get the again actually. So what would be the state? So in what state, the player B is going to be when on first attempt he got tell actually. So he still would be in the same state actually, because he hasn't kind of started yet actually. So he hasn't even started yet, so he's gonna still be in the same. Okay. So A got head, B got tell. So A got head, that means that A is in the state 2. B got head, B got tell, so he's still in the state 1. Then again the turn of the A, okay, he can get head and get tell actually. So if he get head, okay, so he's still in the state B, then the B is going to get the clue. So they're both gonna keep on playing, and then let's see that who completes the pattern first time. Who completes the pattern first? That's what is going to be the game. Okay. So the third state is going to be, for example, head. Okay. Third state is going to be head. I know player 2 is not interested in this state actually, because you want this pattern. Okay. So what would be the fourth state? Tell. Okay. And the fifth, say for example, just put the name head at tell. Okay. So in other words, if the player A reached the state 5 first, the game is 1 actually. 6 is head. Okay. Head tell. So So let's make a picture of it. So what could be the possible ways that in which this chain is going on? So how does the picture of it is going to be? Picture of this like that. 1, 2, 3, 5, 4, 4 can go 6, okay, and 4 can go return back to 1, and 1 can go to 2. So what's your interpretation of the picture actually? Say you are player A, okay? So you played first. So what is possible? So you are here. Okay. So obviously player, okay, so I must say, okay. So you know one of the player is going to be here. So A can be here. And then, what are the probability that is going to in the state B actually? It should be 1/2. And what is the probability that is not going to go? Because both of the player has to go through the state A because both have this common edge actually. So therefore, you can see that the chain, this 2 is kind of connecting the both. Part of the chain. So what will be the other possibility? That you are in state 1. State 1. In other words, the tail appears and nothing happens. So you get even half, I think. Okay. From 2 to 3. In other words, from this to this and this to this.
Half.
Give the half of the probabilities. Okay. And so once you are at the 4, so from 4 to 6, so 4 to 6, so probability is half, and 4 to 1 again.
Yes, sir. You can have head, tail, and tail again.
Tail again. Okay.
So
then,
you will be
then
the
you have to
start.
start again. Have 1/2 and 1/2 actually. Okay. So from 2 to 3, I can go, so in other words, I'm here, and I reach here, so what is probability? Half, and I'm here, and I'm stuck here actually, so.
Again, it's the same state, head, it's the same state, H, both heads.
And what would be this probability from 3? From 3, I can go to there, I can go to 5.
Yes, sir. Either from 3 to 3 or 3 to 5.
3 to 3 or 3 to 5, so 1/2. And once you are here, so you are in kind of an absorbing state or a sink actually, so you can't return. Okay? And 6 is also like an absorbing state. Okay? And then you can write very easily the probability. You can write very easily the probability. In other words, transition matters for this. So the single chain is can represent the dynamics of the both of the players. What I am interested in? I am interested in what is the probability that A wins. What is the probability that A wins? How can I write probabilistically using, for example, these tools? Okay. This event actually. So this is a probability. What is the meaning of having a probability A that A wins? Means you started with a 1 and you end up having 5. Okay. The number of steps are not important. You can maybe reach in 1, 2, or 3 or 4 steps actually. Okay, obviously can't reach in one step. have to take some number of steps to reach there. So this must be, would you agree, this must
F
be
star.
F star 1 5. That's what I'm interested in actually. Okay, I'm interested in F star 1 5. So I'd like to compute this. The question is, from where should I compute this F star 1 5? So if you want to compute F star 1 5, I have to apply what we call my first step decomposition formula.